So we're going to do some probability now. There's definitely higher stuff. There's doing some probability with algebra. So there's going to be some missing numbers. But essentially, this is just forming and solving an equation. It's another type of that. You know, you've had questions, no doubt, before where you might have, say, a triangle, and you might have some of the sides written in algebra. And then it says, you know, write an expression for the perimeter, and then you would have to, you know, add up those sides to get the perimeter, which this case would be, what is it, 11x plus 1. You know, that you'd have the perimeter, and you might have to solve that equation if it gave you some more information. So that's the kind of thing we've done before with forming and solving an equation, but this time we're just going to do it with probability, leading to a very notorious exam question at the end. So a fair spinner has 10 equally sized sectors. So there's a spinner, and it's got 10 segments on it, or sectors, right? Okay, they're all equally sized, so all equally likely to come up. There are n black sectors, and the rest are green. So there's only 2 colours, and the number of black sectors is n. Doesn't actually tell us how many, just says n. So calculate the probability of a black one coming up. Well, think about how would we usually do this. We would do it usually as a fraction. So in this case, it's out of 10 because there's 10 sections in all, and n of them are black. So the probability of black is n over 10. That's it, straightforward, you see. But the probability of green, okay, it's out of the same amount because there's still 10 sectors there. But how many are green? Now, we don't know how many are green, but we do know how many are black. And we know the total. So the number of green would be the total, take away n. So that's what we do. 10, take away n. Yep. And then complete a tree diagram for spinning the spinner twice. Okay, so let's go. Let's give all our little branches there. And we've got possibilities of either black or green, or black, or green, or black, or green. And the probability of black we know is n out of 10, and the probability of green is 10 minus n, because that's how many green ones there must be, the total minus n, divided by 10. And actually the probabilities, this is independent events, you know, the one spin doesn't affect the next spin, not unless you break the spinner. So all the probabilities are exactly the same on each branch, or not each branch, but on each set of branches, probabilities will be the same. So that's the tree diagram done as well. Now, given that the probability of spinning black both times is 16 out of 25, calculate the value of n. Right, now before, we've just been doing some expressions. And it's a bit like writing up the sides on that triangle. You know, we've got the different bits and pieces. And I also formed an expression for something. Now in this time, the expression I'm going to form is from this. Spinning both black both times is equal to this. So let's work out the probability of black and then black. Well, that would be this top journey up here, wouldn't it? Black and then black. Remember, when we've got independent events like this, if I want one event and I want the other event, then I multiply them. So multiplying 2 fractions, you multiply the tops, you multiply the bottoms. N squared over 100. Yep. Now, here's my extra bit of information. I'm told that that probability there is actually equal to 16 out of 25. So now I can write this as that's the expression for the probability of black and then black. But I also know that that must be equal to 16 out of 25. Hold on, the dog has just nudged the cat flap, which means he wants to come back in. So let's let him back in. Hello, Murphy. Yeah, no need to say hello. You just go straight to your food. Right, okay, now we're going to solve it. Now you could, of course, you could do some multiplying here. There's actually, if we notice, there's a little sneaky bit of simplifying we can do first here. Notice all of these are square numbers. Yeah, so if we square root all of this side and we square root all of that side, it will still be completely balanced. I've square rooted both sides of my equation. Right, n squared, if I do square root that, I get n. Square root 100, 10. Square root 16, I get 4. Square root 25, I get 5. Okay. At this point, there's a couple of ways we could do this, but I think the obvious way, if I double this fraction over here, I get 8 over 10. Look, and just to show you, just to put this sort of together, I've got n over 10, I've got 8 over 10. N must be equal to 8. There's no other way that's going to work, is it? N over 10 equals 8 over 10. N must be 8. N has a value of 8. Now that was just the square rooting there and this like making an equivalent fraction. That was just me kind of simplifying and solving. That's not to do with the probability as such. The probability part is just knowing how to form up these little expressions and then using this extra bit of information that they give me so I can then make an equation, in this case n squared over 100 equals 16 over 25. Then you've got to use your ordinary algebra skills to, or number skills, to try and solve it. All right, let's try another one. This time I want you to have a go. You don't need to do a tree this time for this one. It's all the information's there. A fair spinner has 8 equally sized sectors, so they've all got the same probability of coming up. N of the sectors are red, and the rest are blue. And then work out those probabilities. And in the last bit, form an equation and solve. So just like we did before in a way, just without the tree. Pause the video. Unpaused. So what have we got? N of them are red and the rest are blue. Okay, so the number that are red is N. And the number that are blue is the total, which is 8. Take away the number that are red, 8 minus n. So the probability of red will be n out of 8, out of the total. And the probability of blue will be the number that are blue out of the total. So 8 minus n out of 8. If the spinner is spun twice, the probability of it landing on red both times is 9 out of 16. So first of all, let's do the probability of red and then red. Well, that would be n over 8 times by n over 8, which is n squared over 64. Okay, then let's use this little bit of information here. When we spin it, the value of that is 9/16. So the answer to this n squared over 64, is 9/16. Notice again how they're all square numbers on there. I think it's quite deliberate because they're kind of enticing us to do a square root on both sides. Well, n squared will then be n over 8, which equals 3 over 4. Again, I could do a bit of solving here. I could, times it by 4. There's a couple of ways I could do this, but I think the easiest way is to change this fraction so it has the same denominator. So it has 8. To do that, obviously I need to times the top and the bottom by 2 to get 6/8. N must be equal to 6. If n over 8 equals 6 over 8, n must be 6. Yeah. Form an expression, use a bit of information to form an equation, solve it. Okay, so we're going to just try a few of these. Okay, so remember what you need to do here. It's all about forming up that equation, that expression, and then trying to solve it. Okay, so pause the video, have a go. If you get really stuck, then obviously you can unpause and have another go. Get a bit of a hint is what I'm trying to say. Get a bit of a hint and then you can pause it again and maybe carry on. Okay, but anyway, pause the video now and have your best shot. Okay, so have a look at this then. So 3. A fair 6-sided dice has n green faces. The rest of the faces are black. Okay, so probability of green. Well, the number of green is n. There are n green faces out of the total, which is 6. And the probability of black then would be 6 minus n, because it's a total minus the number that are green, must be the number that are black, again out of the total. So there's green, there's black. Now if the dice is rolled twice, the probability of it landing on two different colours is a half. Now there are two different ways that I could get the different colours. I could get green first and then black, or I could get black first and then green. Now the probability of green is n over 6, and then getting black would be times by 6 over n over 6. Now remember, when you're multiplying, the tops will need to be n times the 6 and n times the minus n. You need to times both bits by n. You get 6n minus n squared. 6 times 6 is 36. Now this is going to have the same answer because it's actually the same two fractions. Probability of black times probability of green. It will have the same answer. Don't believe me, try it, but it will do. Now the probability of it being two different colours would be adding together these two ones, because it's OR, isn't it? Remember, OR is add. So I need either 6n minus n squared over 36 or 6n minus n squared over 36. You need to add the two together to get 12n minus n squared over 36. Oh, 2n squared, sorry, minus 2n squared, because it's n minus n squared plus another minus n squared to get minus 2n squared. We can simplify this. All of this could be divided by 2. It could be halved, couldn't it? To get 6n minus n squared. Hang on, that's where we started, right? But over this time, half of 36, 18. So actually, when you double something in a fraction, it's the same as halving the denominator. Keep that in mind because that will come up in a second. Right. So 6n minus n squared over 18 is the probability of two different colours. The two different ways you could do it, but that's the two different colours. Now we are also told, a bit of information here, that that little fraction there is equal to half. So 6n minus n squared all over 18 is equal to a half, right? Well, let's times both sides by 2. Now I'm going to do that. I'm literally just trying to make my life a bit easier here, because if this is equal to half, it'd be a whole lot easier if it was just equal to 1. So if I times it by 2, it'll be equal to 1. I've now got a cat in the way and I can't see a thing. Cat, move your bum. Thanks. Great. Now I've dropped my pad. Thanks, cat. Very helpful. Oh, Tom there. Right, so I times the right-hand side by a half, because by 2. Sorry, times it by 2 because I want it to be a whole number. Let's times this side by 2. And remember, we can do that just by halving this denominator. You double a fraction, it's the same as halving the denominator. So that over 9. Cool, nearly there. Bit of rearranging. We don't want a fraction, we want a straight line. So we're going to times both sides by 9 to get rid of this fraction. So that will cancel out the fraction. So the left-hand side is now 6n minus n squared. And the right-hand side, 1 times 9, is 9. Right, a little bit of rearranging here. Let's add n squared to both sides and take away 6n from both sides. So this side is now 0. And this side is n squared minus 6n plus 9. I'm not going to go into too much detail about that. Hopefully you can see what I've done. Added n squared to both sides, taken 6n away from both sides, just to get it all on the same side. Because remember, quadratic equations, we like it all to equal 0. So get everything away from one side of the equation. If I factorise this, it's going to be n minus 3 and n minus 3. Times them together, I get plus 9. Add them together, I get minus 6n. Right, fine. So my solution there is n equals positive 3. Because remember, you need to make this bracket equal 0. So n would need to be positive 3. Ta-da! All we did, we formed up some expressions, a bit of solving. Now, if anything you found tricky on that page, I suspect it was some of the manipulation of the fractions. Algebraic fractions maybe, not the probability itself. Keep that in mind if you're finding that bit tricky. That's just practice with algebra. Another question for you to have a go at. Circle, good. There was a mistake in this before, but I've fixed it, so it's fine. Good. Okay, so pause the video, try and format your expressions. Use this bit of information down here to form an equation, and then unpause when you're done. Remember, you could always do that thing of just, unpausing for a bit to get a bit of information to see if you can carry on. Okay, unpaused. So 10 cards in the pack. What's the probability that's a triangle on the card? There's 10 of them, and X of them are triangles, so it's X out of 10. And the probability it's a circle, well, the rest are circles, so it's the total. Take away the number that are triangles, so 10 minus X, and divide that by the total to get the probability. The number that are circles divided by the total number of cards. If a card is picked at random, replaced, that's important, and then a second card picked, the probability that the two counters have the same shape is 29 out of 50. Remember, there's two ways that we could get the same shape. That could be the probability of triangle, triangle, put with the probability of circle, circle. Now, triangle, triangle is X out of 10 times X over 10. Which is X squared over 100. The probability of circle is 10 minus X over 10 times by 10 minus X over 10. Right, keep in mind here, when you're multiplying these, now the bottom's really easy, because it's just 100, 10 times 10, but the tops you're going to need to FOIL, because the whole of the top of the left-hand side will need to be times by the whole of the top of the right-hand side. You are expanding double brackets. Now I'm going to go straight to the simplified version here. You might want to do it in a couple of steps and then write it down, but you should have got 100 take away 20x plus, and remember it's plus because it's negative x times negative x, plus x squared. Now the probability then of both the same is the combination of those two outcomes. So it's x squared over 100 plus 100 take away 20x plus another x squared also out of 100, which is 2x squared take away 20x plus 100 all over 100. Okay, so that's the probability of getting both the same. It's just the two different ways of getting the same added together, because this is OR, isn't it? This outcome or this outcome. So all of that. Notice I've put the x squared at the front. As a mathematician, it's kind of good to have it written in this kind of format. Helps us think. Now let's use the extra bit of information in the question. 2x squared minus 20x plus 100 all over 100 is the probability of both being the same, but it also tells us that, well, that actually, did you know that equals 29 out of 50? Okay, now we need to solve. Let's do a little bit of simplifying first of all here. Let's do, let's change the second fraction to being over 100. Let's double the top, double the bottom. That's going to make things easier, isn't it? Because look, I've now got this fraction, which is over 100, equals this fraction over 100. And all I've done is times top and bottom by 2. Now, because one fraction equals another, and they both have the same denominator, we can ignore that and just look at the tops. Because if the denominator is the same and they're equal, well then in that case, the tops must be equal as well. Plus 100 equals 58. Yeah, because the bottoms have the same denominator, just look at the tops. Okay, right, first of all, let's do a little bit of rearranging. Let's take away 58 from both sides to get 2x squared minus 20x plus 42 equals 0. 100 take away 58 is 42. All of these, we can do a sneaky thing here, because much nicer to do it like this. Divide everything by 2. Divide 0 by 2 to get 0. 42 we divide by 2 to get 21. 20 we divide by 2 to get 10. And then 2x squared divided by 2 is x squared. Yeah, that made it easier, because now we can factorise. Quadratic expression, you want to solve it. If you can factorise it, factorise it. Okay, now the two numbers I'm after are x minus 7 and x minus 3. Which means my two solutions, because it did say two solutions, are x equals positive 7 and x equals positive 3. Okay, they can, there's quite a bit of algebraic manipulation in these, but if you're not talking about it, it's a whole lot quicker. Another one for you to have a go at then. Basically, this video is going to be a series of these little problems for you to have a go at so you can see what they look like and see someone talking through how they do the answer. I suppose a bit like a walking, talking mock in a way. You can see someone doing the actual answers. Right, you pause the video, I'll let the dog out. Okay, you've unpaused, and who let the dog out? Who, which of course should be whom. Whom let the dog out? And now he's trying to eat mouldy bird food off a table, which is not very good. Oi, dog, stop it. That's right. Okay, the bag contains 15 counters. X of the counters are yellow. A counter is to be picked at random. Write expressions in terms for X for P is yellow and P is yellow dash. Did you spot that? P is not yellow. That's what yellow dash means. Or what the dash means, not the yellow. Right, a bag contains 15 counters. X of them are yellow, so it's X out of 15. What's the probability of not yellow? Well, that's literally anything that isn't yellow, so that's total. Take away the number that are yellow. That's how many are not yellow. Divided by 15. Okay, if a counter is picked from the bag at random, replaced, that's handy because it's dependent events. Sorry, not dependent, independent. And then the second counter. Sorry, just my dog's trying to eat mouldy bird food off a table, which is really not very good for him. And then a second counter picked. The probability that at least one counter is yellow, at least, oh, that's annoying, isn't it? Will be yellow, is 24 out of 15. Work out the value of X. Okay, right, so here's what we're going to do for this one. We're going to think about the probability of it not being yellow, because that's the only version where we haven't got at least one that's yellow. And then I'll show you what we'll do with that. But let's first of all work out what's the probability that we get not yellow, so yellow dash, twice in a row. Well, that's 15 minus X all over 15. And we're going to times that by 15 minus X all over 15. Okay, remember, you've got to FOIL the top and multiply the bottoms there. It's 225 on the bottom. Right, 15 squared is 225. Take away 30x plus x squared. Let's just shout at the dog again. Who isn't listening to me at all. This is going to make for a really fun video, isn't it? Lots of shouting at dogs. Or rather banging on windows, shouting at dogs. Maybe someone will come home in a minute and sort him out. Anyway, right, so that's the probability of not yellow twice in a row. So what I want to do is do 1 minus that. 1 minus this must be the probability of getting either completely yellows or 1 yellow and 1 not yellow. Okay. And so let's have a look at this. Right. And okay, so 1 minus that. Well, let's change that first bit for a fraction that's equivalent to 1, but is a little bit easier to work with, ideally with the same denominator, so 225. Well, how about 225 out of 225? Clever little tricks. All these little tricks you see, the more you see them, the more you sort of remember it for next time. So one fraction minus the other. Well, the denominator will be 225. 225 take away 225 is nothing. Then I'm going to subtract minus 30x, so that turns into positive 30x, and then subtract x squared, so minus x squared. And now if you found that a bit tricky up to that point, maybe you could work on from there. This is the probability, I'm just going to circle it, of getting at least one yellow counter. If you need to, pause and have another go. But I'm going to carry on. Now I've got my fraction here, 30x minus x squared, all over 225. Now that is the probability of of at least one yellow, and that equals apparently 24 out of 25. Apparently I'm going to have a little moan to myself about no one else in the house dealing with the dog. That's fine. I'm going to let him in now. He's a clever little dog because he bangs on the cat flap when he wants to come back in, once he's finished trying to eat the mouldy old bird food. Okay, right, so we've got this this fraction. That's very distracted today, isn't it? That's how it goes. That's rock and roll maths, that is. Let's change this fraction so it's also over 225. Now, how many 25s go into 225? 4 into 100, 8 into 200, so that's 9, right? So I've times the bottom by 9. So let's times the top by 9 as well. When I do 24 times 9, I get the wonderfully brilliant value of 216. Okay. Right. Now, remember, we've got two fractions that are equivalent here. And if you're not sure, I'm just going to rewrite them again. 30x minus x squared all over 225 equals 216 over 225. Now, because they're equivalent, we can ignore the bottom part of the fraction, just look at the top. It's telling us that 30x minus x squared must equal 216. Right, bit of rearranging. Let's add x squared to both sides and take away 30x from both sides to get that quadratic expression there. Okay, so this one is hard to spot, to be honest, but when you factorize it, you end up with x. And you're going to think, how on earth am I supposed to spot that? But I'll tell you why in a sec. X minus 12 and x minus 18, because 12 18s are 216. Now, of course, you could use the good old minus b plus or minus the square root of etc, 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 which would be 30 plus or minus the square root of 30 squared, which is 900, take away 4ac, which is 264, all over 2a, which is 2. That actually simplifies to 30 plus or minus 6 over 2. All right, so you can, there are ways of doing this without a calculator, but that gives me two possible values. One of them is 12, and the other one is 18. Now, seeing as there are, sorry, let's put that down, 12, either x equals 12 or x equals 18. But seeing as there's only 15 counters, 18 must be wrong, which is why it is 12. Okay, but that factorizing is kind of hard to spot, but otherwise. The other key bit in here was this bit where I wanted the probability of at least one yellow. Well, there's only one version one that isn't yellow, which is not yellow, not yellow. I worked that out, and I just did one minus that probability to show the rest of the probabilities, this bit here. Okay. Goodness me. They're not all quite like that, I promise. They're really not. Bit tricky, that one. Okay, right, read this one yourself. Unpause when you're done. Okay, unpause then. So a bag contains red and blue counters. There are n red counters and twice as many blue counters. So how many blue? 2n. Did you get that? So the probability, so it's only red and blue counters, would be, so picked without replacement, that makes it exciting. Probability of red then is n out of the total, and the total is 3n. And what about the probability of blue? Well, that's 2n out of 3n. Now, this is where it gets a bit exciting. The probability of the second red. Now, if I've already chosen a red, there's now one less red. So there's now n minus 1 reds. But there's also 3n minus 1 in total. Nifty, huh? But there's still 2n blues out of 3n minus 1. There's just one less counter overall and one less red. Now, if I've gone this way, there will be one less blue, so 2n minus 1 out of the total, but one less, so 3n minus 1, sorry. But the probability of red on this set of branches, I've chosen a blue, so there's still n red ones, but the total is 3n minus 1 because there's one less. So we've done the tree diagram. The probability that the counters are both red is 1/10. Now that's up here. Probability of red is n over 3n times by n minus 1 over 3n minus 1. You need to multiply those together. Now when you multiply the tops, you end up with n squared minus n. And when you multiply the bottoms, you get 9n squared minus 3n. So that's the probability of two reds. Hopefully you got that far. Remember, you're picking up marks all the way here, even if you don't finish the whole thing. Then let's go to the top of the page. We've got a bit more space. We're told that that's equivalent to 1/10. So n squared minus n over 9n squared minus 3n is equivalent to 1/10. Okay. Now, with a little bit of rearranging, you times both sides by 9n squared minus 3n, and both sides by 10, and you end up with this, 10n squared minus 10n equals 9n squared minus 3n. Okay, there's a nice little bit of kind of, not symmetry here, but you can see where this is going after a while. So I didn't want it as a fraction, I wanted it as a straight line. There's no easy way to equate the two denominators, so times through by the base of this one, so you get 1 times that, and times this side, all of it by 10, so you get 10 times that. It's just basic rearranging. Let's take away 9n squared from both sides, so n squared, and we'll add 3n to both sides, so now minus 7n equals 0. Work out the value of n. This is one of those ones as once you've done this kind of stuff for a while, I know how to factorize this. Well, let's take n out of both of these expressions, which will leave n minus 7. And we're trying to make that equal 0. That's going to happen at 2 points. Either n is 0, which is the one on the outside, either that is 0, or this bit in the brackets is 0, which is n equals positive 7. Now n can't be 0, otherwise there wouldn't be any counters at all. It has a bit of an existential crisis. Can't have that in maths, so n must be 7. Yeah. I was just looking at the answer sheet that someone else provided for this, and they did it in a very different way. Oh, it's because they divided through by n. Yeah, I could have simplified this all a little bit by dividing through by n, but where's the fun in that? So on this one, I'm going to give you a bit of a head start on this, because it's all to do with yellow and red sweets. If you say that the number of yellow sweets is n, then that's going to help you a little bit, because it just gives you a ratio here of 1 to 4. Now think of that as a fraction. What fraction are yellow? Well, out of the 5 parts, the 1 and the 4 parts, one of those 5 parts is yellow, so it's 1/5. Out of those parts, 4 of them are red, so that's 4/5. Okay, so if the number of them are yellow, are n, I want it to be 1/5 of the whole thing, but I want the top to be n, so I'm going to times the top by n and the bottom by n. That is going to be, if n is the number of yellow sweets, the proportion that are yellow is n out of 5n, right? I'm going to give that to you. The proportion is that, which means the probability of getting one yellow is n out of 5n. That will get you on a good start down to this. It's without replacements, so be a little bit careful. Pause the video, unpause when you're done. Unpaused. Now, the probability of one yellow is n over 5n, but what about two in a row? Because that's what we're talking about here. What's the probability they're both yellow? Well, that'll be n over 5n times by, now the next one, there's one less, so there's n minus 1, over one less of the total, so 5n minus 1. Multiply the tops, n squared minus n. Multiply the bottoms, 5n times 5n is 25n. 5n times the minus 1 is minus 5n. Okay. Now, it says on my bit up here that that is equal to 1 over 35. Okay, so at that point, we're going to do a little bit of simplifying. We've got all of this here. Let's just box it in so I can see what I'm looking at. I want to get this into a straight line, so let's times both sides by 35. Now that effectively makes 35n squared minus 35n there. And both sides by the bottom of this fraction, so that'll be 1 times that to get 25n minus 5n. Okay, if you're not sure about that, you can do it in a couple of steps, but I'm just trying to speed up the explanation here and get onto the key material. Right, bit of clearing up here. Oh, I forgot. There's 5n times 5n. That was 5n squared in there. Just correct my working. So that's 25n squared. Let's add 25n squared to both sides. So this now is 10n squared. And we'll add the 5n to both sides as well. And that will remove both of these things from that side. Adding the 5n means this is now minus 30n. Now, once you've done a few of these, you kind of spot what you've got to do. Let's factorize this. I can divide 3 by 10. Let's divide that by 10. Let's divide that by 10. Let's divide 0 by 10. Happy days. And then factorize it to get n. Can just go outside the bracket to get that. Now this is going to have two solutions. Either n is 0. That's the n on the outside there. Either that is 0, which would make the whole thing equal 0. Or the bit inside the bracket might be 0, so that would have to be n equals positive 3. Okay, again, that's only going to happen really when n is 3, because we can't have 0, otherwise there'd be no yellow counters, there'd be no red counters, there'd be no counters at all. And just out of interest, there are 15 counters in total. Number 8. A bag contains black and white tokens. There are 3 times as many white tokens as black discs. White tokens and discs. Okay, there is black and white tokens, all right? And there are 3 times as many white tokens as there are black ones. So if we got black, we've got white, that means we've got 1 to 3, which means there is 1/4 a black, 3/4 a white. Okay, if 2 tokens are picked at random without replacement, the probability that they will be the same color is 3/5. There are 2 ways we could do that, aren't there? We want to know how many black tokens are in the bag. So let's say the black tokens is n. Just like before, that means the number of black ones, or sorry, the total number is going to be 4n. Because if the number of black is 4, sorry, oh god, let's try it again. Number of black is n, and 1/4 of them are black, then there must be 4n. That's the total number of tokens. Total number of tokens. That's what that says, honest. Right, what's the probability of black and then another black? And there's no replacement here, remember. So the first one will be the number that are black, which is n. We said, because that's what we said right at the start, we're making n the total, the black ones, out of the main total, which is 4n. Then if we selected one black one, there'd be one less, so it's n minus 1, out of 4n minus 1. Multiply those together to get n squared minus n over 16n squared minus 4n. Yes, Murphy? What about the probability that they are both white. Well, that's the probability of white and then another white. Well, what's the probability of the first white? Well, there are 3n white ones. If n is the number of blacks and there are 3 times as many whites, there must be 3n white ones out of the total 4n. And the next one, there would be 1 less white token out of 1 less token overall. Multiply these together to get 9n squared minus 3n over 16n squared minus 4n. All of those have got n, so we could divide through by n, but you can get tricky things doing that if you divide through by n. Not being careful, because you can actually end up losing one of your solutions. So I'm going to leave it like that for now. So let's add those two things together to get the main total, because we have 2 possibilities, either black black or white white. So let's add those together. Notice they've got the same denominators as well, so that's handy. N squared minus n over 16n squared minus 4n. That's black black, and then white white is 9n squared minus 3n, all over the same denominator, 16n squared minus 4n. So the probability we're after finally is 10n squared minus 4n over 16n squared minus 4n. Phew! Now it tells us that that is equal to 3/5. So let's do a little bit of solving here. So let's times both sides by 5 to get rid of this denominator, and then times both sides by the bottom of this one. Once you've done that, you end up with 3 times this, so 48n squared minus 12n. And this side you times by 5 to get 50n squared, take away 20n. Bit of rearranging, so let's take away 48n squared from both sides and add 12n to both sides. 2n squared minus 8n equals 0. Let's divide everything by 2, just to simplify it down. Factorize it to get n brackets n minus 4 equals 0. So either n equals 0, remember that's the n on the outside of the bracket. If that's 0, everything is 0. Well, it can't be that one, because otherwise there'd be no question. There wouldn't be any counters of any kind. Or n equals positive 4, which is what that must be, he says, looking over it. Yes. Okay, so n equals 3 for that one. N equals 4 for that. Now, I did have a couple of other questions for you, but these ones have taken quite a long time. So what I want to show you instead is straight onto this. This is Hannah's Sweets. Right, so back on the 4th of June 2015, Twitter in the afternoon and studentroom.com or whatever it is exploded, and it made national press for about 3 days. This question came up on an exam called Hannah's Sweets, and it prompted tweets like this. So I hope I never get another question on sweets in a maths paper again. The probability of me getting a good grade in this exam is 1 out of 1,000. How many sweets does this mean I have? I have. Edexcel Maths and GCSE exam, hardest things to ever hit the human race. And they did get particularly silly after a while. This is actually me when Hannah's stupid sweet came up. What's the point? Seriously, what's the point? Hannah has 6 yellow sweets. Prove that n squared minus n minus 90 equals 0. Me. Well, that escalated quickly. Or you shall not pass. This went on literally the few days. This is my personal favourite. Hannah eats some sweets. Calculate the circumference of Jupiter using your tracing paper and a rusty spoon. 5 marks. And this is the question that prompted all of that. It is exactly what we've just been doing here. Now, if you're feeling brave, it's not actually that hard. I think compared to some of the ones you've just looked at, I don't think this is too bad at all. But pause it, unpause when you're done. By the way, this isn't the whole question. There were a few other marks afterwards, but this is the first bit that confused so many people. All right. Anyway, pause, have a go, and unpause when you think you've done it or given up. Right, there are n sweets in a bag. Why always n? 6 of the sweets are orange. The rest of them are yellow. Hannah takes at random a sweet from the bag. She eats the sweet. Hannah and her sweets. Crazy girl. Hannah then takes that random another sweet from the bag, and she eats the sweet. Crazy girl. What's the probability? Oh no, sorry. The probability that she eats 2 orange sweets is 1/3. Show that n squared minus n minus 90 equals 0. At which point everyone went, what? What are you talking about? What's that got to do with anything? It's because they didn't realise they needed to form and solve an equation. The probability of orange and then another orange is this. The first orange is 6 out of the total, 6 out of n. The second orange one, well, if you'd eaten one, there would be one less. So that would be not 6 anymore, it would be 5. But the total is also less as well, so it's n minus 1. Right, multiply those together to get 30. Out of n times n is n squared. N times minus 1 is minus n. Okay? Right, so you formed that up. But it also tells you that probability of the 2 orange sweets is 1/3, so you write that as a third. And do what we did before. Let's do that thing where we do a bit of cross multiplying. Let's times both sides by 3 to get rid of that denominator, and times both sides by n squared minus n to get that denominator. Easy, just take away 90 from both sides of your equation. 0 equals n squared minus n minus 90, right? Compared to what we've just been doing, that's really easy. And yet people found that really hard in the exam, and it literally was in the news for about 3 days at the time. And then I said it did go on a little bit from there. You could solve it to find out how many were in there. In fact, we could do that now, couldn't we? Let's do that. I might have to use, I don't know, was it 10 times? Oh, there we go, 10 and 9, isn't it? So if you do n minus 10 and n minus 9, n has got 2 values. Either n is 10 or n equals 9. And that would still work for both of them. The question went on, and probably there was something on the next part, B or C, that meant you could choose which one it was out of those 10 or 9. Okay? Anyway, well done. See you next time. Bye-bye.